viewers, welcome to video number 63 of the channel Chemphilic. Video number 63 is the 5th episode of Chemical Thermodynamics. In the 5th episode of Chemical Thermodynamics, I will discuss about extensive and intensive properties. So, let's start. Thermodynamic properties. So these are the properties which tells us about the nature of the thermodynamic system, and these thermodynamic properties are of two types. Number one, intensive property. What is that? These properties are independent of the amount of the substance present in the sample. It depends only on the nature of the substance and independent of the amount and size of the sample. So this is intensive property. Second one, extensive property. Extensive property is just opposite of intensive property. That means extensive properties depend on the amount of the matter or substance present in the sample. And one more thing, extensive properties are additive. I'll explain this in the next slide. Now, let's take some examples. Say for example, length. I have taken one scale whose length is 10 centimeter. If I take another identical scale of length 10 centimeter and put them together, that means the amount of the matter becomes double. Then you will see length also becomes double, that is 10 plus 10, 20 centimeter. So length depends on the amount of the matter, so it is extensive property. Now coming to volume. Let's take 100 milliliter water in this beaker. Now in the same beaker, in 100 milliliter water, we have added another 100 milliliter water. That means now the matter or amount of the substance or amount of the water molecule becomes double. Volume also will become double. 100 plus 100, 200 milliliter. So volume depends on the amount of the substance or amount of the particles present. So volume is extensive property. Then coming to size. So this rectangle size is 8 by 10. Now two such rectangles, that is of size 8 by 10, if I put together, then total size will be 16 by 20. Here two rectangles I have taken means the amount becomes double, size also becomes double. So size depends on the amount, so it is extensive property. Now heat energy. Now let's take this beaker which contains one liquid at 60 degrees centigrade and volume is 100 milliliter. And in an identical beaker, we have taken 200 milliliter of the same liquid and the temperature is 60 degrees centigrade, same. Now let's calculate how much heat energy is present in this liquid, in this beaker, and also in this beaker where 200 milliliter liquid is present. Let's calculate. So, in the first beaker, amount of heat energy will be 100 into 100 is the volume into 4.186 into 60, that means 25,116 joules, and here it is 200 milliliter water. So, 200 into 4.186 into 60, that is 50,232 joules. So, here when the amount, here the volume is 100 milliliter, here 200 milliliter, that means amount of the liquid is double, heat energy also becomes double. So heat energy is extensive property. Now coming to this one. See, here we have taken 100 milliliter water in this beaker, here in the next beaker 200, the third beaker 300, fourth beaker 400 milliliter water. Then not water, sorry, some other liquid. Now, if all this liquid, that means the liquids of all this beaker, if I pour it in a big beaker, then I will find that volume of this liquid in this beaker will be 1000 milliliter, which is the sum of the liquid present in this small beaker. That means in this subsystem. So, these extensive properties are additive, or extensive properties of the subsystems are additive. Now coming to another example, so boiling point. Here I have taken water in a small beaker, here it is in a large beaker. That means amount of water is more. Both are boiling. But the boiling point, both are boiling at the same atmospheric pressure. Boiling point will be same, that is 100 degrees centigrade, independent of the quantity of water. So boiling point is intensive property. Now coming to temperature. Once again the same example. Two beakers, we have taken two same liquids at 60 degrees centigrade temperature. If both the liquids are taken in this beaker, then volume will become 200 milliliters. So volume is extensive property, but temperature will remain same, that is 60 degrees centigrade. So temperature is intensive property. Now coming to luster. Luster means the shining property. How that substance reflect the light. Okay. So whether this mineral is a bigger size or smaller size, shining property or reflecting of light property will be same. That means luster depends on the nature. So it is intensive property. Then color. So I have taken one big ball of red color, one small ball of red color. Here the amount is more, but the color will be same whether the quantity is more or less. So color is intensive property. Then coming to taste. This is sugar cube and this is fine particles of sugar. If you taste it, you will get the same sweet smell whether it is sugar cube, big sugar cube or fine particle of sugar. So taste depends on the nature. So it is intensive property. Now, identifying intensive and extensive property. So, once again, I am taking the same example. So, here 100 milliliter water at 60 degrees centigrade, not water, some other liquid, sorry. And here also 100 milliliter liquid at 60 degrees centigrade. When both are taken in this beaker, then 200 milliliter liquid at 60 degrees centigrade. So, here when these two identical sample, that is 100 milliliter liquid, 100 milliliter liquid are put together and this volume becomes double, then this volume I can say it is extensive property. So one easy way to tell whether a physical property is intensive or extensive is to take two identical samples of substance and put them together. If the property doubles, then it is extensive property. But here you see temperature, even the amount is double, but the temperature will remain same 60 degrees centigrade. That means if the property remains unchanged, then it is intensive property. So temperature is intensive property. Now another point is, it is also very important, the ratio of two extensive property is an intensive property. Say for example, density. Mass by volume. Mass is extensive property. Volume is extensive property, we know. So, this ratio density is intensive property. Using these 2 points, you can identify whether any thermodynamic property is intensive or extensive. So, identify the following as extensive or intensive properties. First one, number of moles, we know it is extensive property. Then volume, we know already we have explained, it is extensive property. But molar volume, that is volume by number of moles, one extensive property divided by another extensive property, that is the ratio of two extensive properties. So molar volume is intensive property. Now concentration. Concentration is number of moles, or it is the ratio of the number of moles and the volume of the solution. So it is the ratio of two extensive property. Therefore, it is intensive property. Then enthalpy. Enthalpy is the total heat content. I will explain in the coming videos. So this enthalpy depends on the amount of the substance. The total heat content depends on the amount of the substance. So enthalpy is extensive property. Now enthalpy per mole. See here, enthalpy extensive property, number of moles extensive property. So their ratio, that is enthalpy per mole, will be intensive property. Then mass, we know it is extensive property. Then density of solid and liquid. Density of solid and liquid is mass, which is extensive property, divided by volume, which is extensive property. That is the ratio of two extensive property. So density is intensive property. Then coming to conductance, capacity to conduct electricity. Say electricity in the electrolytic solution. So it depends on the number of ions per unit volume. So when the number of ions increases, conductance increases. That means when the amount of the electrolytic solution increases, conductance increases. So it is extensive property. But conductivity or specific conductance, which is the conductance of 1 cc solution, that means which is the ratio of this conductance and volume. That is, this is also extensive, this is also extensive. So therefore conductance is intensive property. Now entropy. Entropy is nothing but energy. Means energy which cannot be used for doing useful work. So this entropy or energy term is extensive property. Now molar entropy. Molar entropy is the ratio of entropy and number of moles. Entropy extensive property, number of moles extensive property. So molar entropy is intensive property. Now Gibbs free energy. Once again this energy, that is extensive property. Then Gibbs free energy per gram. That means it is the ratio of the energy and mass. Both are extensive property. So this ratio is intensive property. So Gibbs free energy per gram, intensive property. Then heat capacity. Heat capacity is the amount of heat required to increase the temperature by 1 degree centigrade. If the amount of the substance is more, then more heat is required to increase the temperature by 1 degree centigrade. So heat capacity is extensive property. Now molar heat capacity. Molar heat capacity means it is the ratio of heat capacity and number of moles. That is heat capacity divided by number of moles. Both heat capacity and number of moles are extensive property. So this ratio is intensive property. So molar heat capacity is intensive property. And coming to refractive index mu. Refractive index means when the light passes through a medium or any substance, how much it bends. Okay, and how much it will bend, that depends only on the nature. Whether you take the small size substance or big size substance, how much light will bend, that is independent of the size or matter. So refractive index is intensive property. Then viscosity. Viscosity depends on the nature of the liquid. So it is intensive property. Then EMF. EMF is electromotive force. It is the difference between the electrode potential of the two electrodes in the galvanic cell. And electrode potential depends on number of ions per unit volume. So electrode potentials are intensive properties. So their difference also intensive property. Now magnetic permeability. Magnetic permeability means that induced magnetic field developed when the substance is kept under a external magnetic field. That depends on the nature of the substance. So magnetic permeability independent of the amount of the substance. So it is intensive property. Then Next, molality. Molality is number of moles divided by weight of the solvent in kg. Now, number of moles and weight of the solvent both are extensive property. So, this ratio, that is the molality, is intensive property. Then coming to pressure. Pressure is intensive property. If you take a gas in a container and then you just make the container half, you just put a partition and make the container half, then in both the half pressure will be same. So pressure, though the amount become half, but the pressure will remain same. So pressure is intensive property. Now state of matter, that is solid, liquid or gas, that depends on the nature of the substance. So it is intensive property. Now specific heat. Specific heat means the heat required to increase the temperature of 1 gram of substance by 1 degree centigrade. So it is the ratio of the heat required and this is the amount in gram. Okay, because it is for 1 gram, so you have to divide by the weight or amount in gram. So therefore, specific heat is the ratio of two extensive properties, so it is intensive property. The density of the gas at constant pressure. Say you have taken a gas in a container and the pressure is constant, and then you are adding more and more gas. That means amount you are increasing, but the volume is not constant, so volume also increasing. So this m by v, mass also increasing, volume also increasing, m by v, that is density will become constant. So density of the gas at constant pressure is independent of the amount, so it is intensive property. But density of the gas at constant volume, so you have taken a gas in a container and volume is kept constant, and then if you add more and more amount of gas, then what will happen? Gas will be accumulated in the same volume. So the amount of the gas increasing, but the density is not intensive property. It depends on the mass of the gas. Therefore, density of the gas at constant volume is extensive property which depends on the mass. So this way you can identify whether any thermodynamic property is intensive or extensive property. Hope you have understood. Thank you.